M6C2 test electric fields. Question 7, which reads, an electric field is set up using two plates that are 50 millimeters apart. The potential difference across the plates is 12 volts. An electron is injected into the gap between the plates and spends a total time of 2 microseconds within the field before exiting the field. Calculate the change in velocity of the electron as it leaves the field between the plates. Bit of a tricky one, this one, but the solution itself is not too hard. But reading the question and understanding what to do is a challenge. So over here on the left, I'm going to sketch out a few ideas. One is the electric field strength between two plates is determined by the potential difference across the plates divided by the distance between the plates. Couple that with the defining equation for electric field strength, which is the force experienced per unit charge. Rearrange and we can get an expression for the force experienced by that electron while it's between the plates. And that force would be the potential difference across the plates times the charge, which in this case would be the electronic charge, divided by the distance between the plates. Over here on the right hand side, I'm going to sketch out another idea to do with Newton's second law, where the force is equal to the rate of change of momentum. So I'm just going to change these differential d's into sort of deltas so that we've got a sort of manageable change in momentum to work with here. Momentum is mass times velocity, so substituting that into this equation, mass isn't going to be changing, it's just going to be the velocity that's changing. And as an aside here, this will then become force equals mass times, and this is rate of change of velocity, which is acceleration. So this is force equals mass times acceleration, F equals ma. But I digress. What we are now able to do is join together the two expressions for force at the bottom and rearrange to make the change in velocity the subject, and that would give us this equation here, where the change in velocity can be calculated potential difference across the plates, charge on the object, which will be the electronic charge here, the time between the plates, which is 2 microseconds, divided by the distance between the plates, 50 millimeters, and the mass of the charged object, which in this case is an electron, 9.1 times 10 to the minus 31 kilograms.